Yeah, I think I'll get started right now. All right, so I just want to welcome everybody. Thank you guys for all coming to your HackFS judging session, which will start right now. Yeah, so just going over some quick statistics of this event. We've had 650 hackers from 61 countries and 18 time zones. So it's just really great to see like everybody from the Ethereum community coming out all over the world to come participate at this event. And just for you guys, the attendees, I'll give you guys a quick overview of the judging format. In total, you have 7 minutes per team, 4 minutes for a demo, and 3 minutes for a Q&A session with the judges where they'll be able to ask you guys questions about your project and inquire more about it. And then we'll take a 10-minute break for every 6 to 8 teams. We don't have that many today, so I don't think so. We'll probably take a 10-minute break at around 5. And the judging criteria is based off of 5 key points, which is technicality, originality, practicality, UI, UX, DX, as well as the wow factor of your project. And a friendly reminder, it's good to keep in mind that this is not a competition. We are here to learn, we're here to explore what's possible, and not all of us are aiming to become successful businesses or anything. And the main focus here is just to get feedback and overall just to create a strong Ethereum community here at HackFS. So yeah, and I'll give a quick introduction to our judges. We have Carson from textile.io, and we have Vijay from BitsCrunch. If you guys could give yourselves a quick introduction.
Hi, Carson here from Textile. This is my second, well, it's the second and my second HackFS hackathon as a sponsor, and I was pretty excited to be engaging with everybody in the channels and things like that, and looking forward to seeing what you all have built.
Cool. So myself, Vijay, living in Munich, Germany. I'm one of the founders and the CEO of BitsCrunch. So we are currently operating in Germany as well as in India, and we are one of the sponsors for this event as well. So previously, a few events back, I was in the organizing team, but yeah, it's good to be on the other side of the event now. Good to be judging this event. So yeah, looking forward. Thanks.
All right, fantastic. I'm looking forward to it as well. So let's just get right into it, I guess. Yeah, so I would like to just ask team Games Vault to come up and present your presentation. So reminder, 7 minutes in total, 4 minutes for your video presentation and 3 minutes of Q&A. So you guys should share your screen real quick. Right.
Hello, everyone.
Hello.
Hey there. So I'll share my screen. Is that working?
Looks like it. Yep. We can see welcome to Games Vault and your sign in with MetaMask button.
Are we supposed to be hearing sound right now? In your video?
So you're getting sound through?
No,
no, we're not.
No.
Okay. Yeah. Okay. Pretty common problem.
Sure. So we'll go back to the main. Should have sound.
Yeah, so if you don't know how to do it, I don't know if you got it.
I think this should be working now.
Okay.
Hello and welcome to Games Vault, a decentralized ecosystem for PC gaming. The problem with the PC game marketplace today is that a handful of massive companies have a monopoly over discoverability, content requirements, exclusivity, and take up to 30% of sales revenue for the privilege of using their platforms. Our vision is to create a community-owned game marketplace where developers receive 100% of their sales revenue and consumers have true digital ownership over their games. Let me walk you through the MVP we've developed for HackFS. First, we need to sign in with MetaMask. Next, we need to switch to the Polygon network. Here you're presented with a store page, which lists some games added earlier for demonstration purposes. All game data is stored using Textile's ThreadDB, and here on the left, you can see we're retrieving tags from the game's database. You'll notice all the games are priced in Matic, but technically we can use any currency, even credit cards, using Unlock Protocol. Let's take a look at some of the games. Here you can see the game listing for Cyberpunk. All game assets, marketing images, and even the game builds are stored using IPFS Web3.storage technology. On the right, you can see the price, but 60 Matic is a little bit too expensive for us, so let's find a cheaper option. So here on this game, you'll notice that the price is much cheaper. So let's go ahead and buy this game. So we want to confirm the price, confirm. What's actually happening here is I'm buying an NFT which the developer minted when publishing the game. This NFT will give me lifetime access to game updates, but can also be sold or traded on open marketplaces. Completed, and it was successful, and that purchase button is now turned into a download button, and we're able to download the game. And this downloads a zip file, or it could be an executable, or any sort of file that the developer chooses to upload for their game. And this is all stored using Web3.storage. And you can also view your purchase games in your library. Using the graph, we're able to retrieve a collection of all the games that the user owns. Next up, we'll go to the developer page. So I'm already registered as a developer, but if you're not, you're presented with a sign-up screen, and you can pay a small monthly subscription using the Unlock Protocol in order to get access to the developer dashboard. Once you've got access to the developer dashboard, you can add your games, you can edit your games, you can publish your games, but you can also update your developer info here, which is publicly displayed. So what we're going to do now is we're going to add a new game, and I'll show you how that works. Right, let's click publish. What this is actually doing now is it's minting an NFT, which represents the game, using Unlock Protocol. So as you can see here, this game has now been published. So we can go to the store page, and we can see indeed that Red Dead Redemption has been published. And it's available to buy for 30 Matic. Cool, so that's our demo.
Yeah, so you guys can move on to the Q&A session now. The judges have any questions?
Brilliant. Yeah, if you guys have any questions, we're happy to answer anything that you got.
Yeah, I can kick us off, and actually I'll turn my video on here. So for the when I noticed that there's no fee for uploading or publishing a game, so the platform, does it effectively, in theory, make money based off of like sales of the NFTs? Does it take a cut or something like that, or is it purely cut free and everything just goes straight to the uploaders?
Yeah, so in terms of sort of monetization models for Games Vault itself, one thing that we really want to do is offer developers the opportunity to get 100% of revenue. So in terms of monetization from our end, what we're looking at doing is offering sort of premium placement. So kind of similar to in the UK, there's a site called Gumtree, where you can list as many things as you want for free, but you can pay for premium sort of space. So this is kind of a completely different model to what most games platforms are doing at the moment. We want completely free, like 100% of royalties going to developers, and they can even take their games and they can sell them on other platforms because it's completely decentralized. But if they want to use our platform and they want premium sort of placement on the store, they can pay for that. Also, we get a cut of we get 100% of the developer fee as well. So developers have to pay a monthly subscription using Unlock Protocol, and that goes to us. Cool.
Great. So first of all, Henry, it's a good project. So you did a good job. So are
nice.
you
Thanks very much.
doing it alone, or you have a team?
Yeah, so we've got Mario in the channel as well. Okay. So me and Mario both worked on it. So it's a two-man team.
Okay. And then what about the future plans? I mean, what about the roadmap? How are you going to proceed from here on?
Yeah, well, this is our first HackFS and actually our first Web3 project. We've got a little bit of front-end experience, but mostly we're game developers by profession. So now that we've built this, we're aware of some potential funding, sort of game-specific funding. So we're going to take this demo and we're going to put together a deck and we're going to pitch it as a potential project and try and secure some funding and build it into a full project.
Great. Yeah. Cool.
Nice. Thanks.
And just another question from my end maybe is, so in theory, I could upload a game asset for a game I didn't develop. So there are any, you know, you don't have to, it's a hackathon, so you don't have to have this figured out, but are there any thoughts about how you might do sort of, you know, curation and takedowns and things like that?
Yeah, that's a difficult one. One thing that we want to do is some sort of community moderation. So one thing we were thinking of is that we were going to have a thing called a Games VIP pass, Games Vault VIP pass, and that allows, once people own that pass, they get free games monthly. But another benefit of that is they get sort of curator privilege, and they can kind of sort of let Games Pass go through or do like a certification process, and they can help out with that. We're kind of new to that. We're kind of new to sort of community moderation and things like that, but that's something that we'd like to explore. But in terms of DMCA takedowns and stuff like that, I've got no idea how that sort of stuff is managed usually.
The gamification of curation is very interesting. That's a cool idea. I like that. You sort of, there's a benefit in addition to like having the control of community moderation.
Yeah,
that's
absolutely.
smart. I like that. It's a neat idea.
Cool.
All right. Yeah, so time's up for the Q&A session. That was a great presentation. Thank you, Games Vault, for presenting your project.
Thanks, Games Vault.
Brilliant. Thanks very much. Thanks for having us.
Thanks.
Right. Up next, I would like to welcome Team Scholar DAO. If you guys could come up and present your project. Rajdi?
Hi, yeah. You able to see my video?
Yes.
I don't think we're hearing audio right now. Yeah. So if you could unshare your screen and then click share screen again.
Sorry, just an entry. Just open access.
Okay, that's good.
There we go. Start it again though.
Yeah, I don't hear anything right now.
No sound.
Yeah. So just stop sharing your screen right now. Like exit out.
Are you able to see it?
We can see it, but we can't hear it.
Okay. I'm sorry.
Stop sharing your screen and then click share screen again. Don't select your window just yet, but you have to find the option to share sound at the bottom left.
Okay.
And then once you turn that on, we can hear the audio.
Hey everyone, I'm part of the team at Scholar DAO, and we're trying to make scientific peer reviewing system more transparent, verifiable, and open. We have 2 front-end and 2 back-end developers on our team. There's a lot of problems right now with the scientific publishing system. Here are just a few. There's a lack of transparency, so peer reviewer matching, which is facilitated by journals, inevitably leads to bias. There are huge barriers to entry because open access journals are costly for authors to publish on, and closed access journals are expensive for readers to access in the first place. There's warped incentives because of high processing fees that lead to authors and reviewers being unable to monetize their work. And there's a lack of an open reputation system. There's several centralized citation indices, but no open protocol that indexes all papers together in decentralized fashion. And there are many impact factor formulas, which are formulas that calculate the average number of citations your paper has received. And because there are so many of them and different journals follow different conventions, you never know which paper is making the greatest impact. We solve these issues through utilizing many technologies. We use decentralized storage, open reviews and validation, ownership by default, and an open reputation system. More is detailed in the demo.
Okay, so now I'm going to upload the paper. So I have filled in the entry for title, the field, the specific field, the validator tip in either, and the validator address. So now I'm going to upload the file. So should be Ethereum yellow paper. Okay, then I submit it. Okay, confirm. We should have 9 papers. Okay, so this paper is still in draft stage, and now I will use a validator account who will act as the editor of a journal. And then I go into paper number 9, accept the validation request, and confirm the transaction. Okay, so we'll reload the page again. Okay, now the paper is in stage preprint. And you can see here there is this and then the IPFS needs to work. So we have already submitted into the IPFS, and yes, this is the Ethereum yellow paper. Okay, so now I'm going to use my review account to add a review here. So let's say I want to add the review here, and then paper review. The decision is accept this paper. Okay, this page. Okay, confirm. There should be a review. The new review. Yes. So it is reviewed by Scholar to accept, and yeah, we can review the review. So let's say I'm going to use my validator account to publish the paper. Here we go. Now the paper 9 is in stage published.
Okay, now let's talk about the reputation system of Scholar DAO. So we use a subgraph to fetch different events happening in our smart contracts and then index them on a graph node and then expose them through an API. So as you can see, there are like 2 papers here and then 1 scholar that has been indexed so far, and this particular paper references this paper ID 4. So that means this paper gets 1 citation from here, and this particular author or scholar improves their number of citations. And we're also computing the H index, which is a measure of productivity and the number of citations achieved by a scholar in the different publications. Thank you so much for watching. Yeah, so that's it.
Yep, judges, you guys can go ahead.
Okay, cool. Great presentation. Thanks very much. So how are you using a service to upload to IPFS, or how is the IPFS integration?
Yeah, we are using the web3.storage library for that.
Okay. Great. And is the H index, is it calculated, like where is that calculated in?
So we have, yeah, it's done in the smart contracts as well as in the graph node as well. Like in the subgraph, we fetch events from the smart contracts about, like, let's say 1 paper references another, and then we compute the H index in a function on the graph.
Right. Okay. And obviously the index depends on essentially this being a closed system in which all papers are included in
Yeah,
the system.
right. Yeah.
Yeah.
So we did think about like onboarding other researchers as well and verifying their identities using an Oracle, but then we fell into some errors and then we skipped that part for now.
Yeah, I mean, that's a pretty tricky onboarding issue. Well, okay, I have other questions, but Vijay, if you've got one, go for it.
So, nice one, Rajib. So it's a good work. And what about the business model? I mean, if you are looking to scale up this business.
Yeah, so the validators are just like editors in a regular journal system, editors or just journals. And then they would need to stake some amount of tokens into our DAO. And then their tokens would be slashed in case they miss the publishing deadlines or if they have a lower reputation. So the reputations are available openly. So there won't be like Sybil attacks or something. Like I could make another, I could just impersonate another scientist, but then my reputation would be low. So then it wouldn't really matter if I have different accounts. So, and then we also thought about having a funding model in which people can just use quadratic funding to fund the reviewers and the authors as well, if they want to like get a paper published or research done.
So what was the, you mentioned some technical issues. Oh, sorry, Vijay, did I just interrupt?
No worries.
Yeah, so the technical issue, one of them was with Chainlink, in which we were having some problem connecting the contract with the Chainlink Oracle node. So that was one. And then in the graph part, we had some problem like hosting it on the Graph Explorer. It wasn't indexing it fast, so we just ran it on a local node.
Sorry to interrupt, but I know Vijay, you had a question, but we don't have we ran out of time for the Q&A session. So
It's fine. Yeah,
Okay,
let's move to the next
Thank you
one.
so much.
So yeah, I just want to, up next we have Team Brainiumverse. So I'd like you guys to start when you're ready. Start presenting your presentation. And thank you so much to Scholar DAO for presenting.
Let's do this again. I lost. Can you see my screen?
I can see
No,
you.
I don't think so. No.
See me. Okay. Oh yeah. Well, I'm trying to find the share button.
Okay. Thank you.
One second. Let's do this again. Okay. I think I got lost there. Okay, there it goes. Screen.
Yeah, and don't forget to select the share sound option at the bottom left.
Mapping the real world. Can you hear me? Nice space of bringing. Yeah.
We can hear you, but we can't see you.
Yeah.
Okay.
Or we can see you, not your screen though.
How about now?
Training. Mapping the
No,
real.
Just you.
Nice
Just me.
space of bringing. Yeah.
How are you trying to share your screen? Are you pressing the green share button at the bottom?
Share screen. Okay, so I got to do it in here.
Yeah, and make sure to select the share sound option on the bottom left.
Yeah, I think.
There we go.
Yeah,
All
there
right.
we go.
Too many windows up. I just get confused. Sorry.
Training.
Is that it?
Mapping the real
Yep.
world. Okay, mind space of Brainium AI. The pseudo AI to simplify life and its interactions. Crypto and Ethereum are powerful but complex. With all the new terms and systems, this complexity is preventing faster adoption by the public. Public keys, private keys, smart contracts, gas, to regular folks, all mined anonymously. However, crypto's power can be used to simplify its usage. How? Brainium works. Real-world objects and entities are mapped into smart contracts. Interactions are handled by executing smart contract functions. All these interactions will create a knowledge base. The pseudo AI can use this knowledge base to learn. Over time, it can perform these transactions or even recommend others. The end result is an automated and simplified with the stack. Yeah, Brainium AI, the DAO for governance, an economy for payments, cloud for data storage, and it's built on top of the decentralized, centralized systems and systems like Ethereum, IPFS, Filecoin, Web3 storage, NFT storage. How do we experience Brainiumverse? Teleporting. It's like jumping from one reality into another. It's totally visual. Brainiumverse simplifies life. We know what we want. Brainiumverse takes care of the interactions and crypto complexity. And maybe that is why crypto is complex. It is for machines. The end. So we're gonna just start Brainium AI. It's gonna chug in the background. And we're gonna teleport to, so let's say, AC department, events department, and maybe we can pause the teleporter for a second, purchase a suit or something. We can continue teleporting and go, let's say, to Starbucks and meet a friend, or visit the Brooklyn Museum. You can even go to a random scene, just teleport somewhere. Teleport home, see what's going on. Nobody's on. Teleport and see what's going on globally. You in this inception. Yeah, meet your friends. Yeah. Wow. And teleport to different cities and see what's going on. A live event. Or even teleport down the street and see what's going on. So yeah, you can pause a teleport and you can continue. You can end the teleport and we'll go back to the main stream. You can pause and everything. So basically, this is the navigation. Now we teleport around. But to populate Brainiumverse, we have to create NFT citizens. Yeah, create an NFT for your home address, link roads, create stores, companies, and real-world assets. And then all the interactions will be what helps create Brainiumverse. So it's a different way of looking at things and very interesting. Thank you very much.
Right. Thank you so much for your presentation. And we'll be moving on to the Q&A session now. So, yeah, judges, take it away.
Cool. That's a very futurism, very exciting sort of presentation. I'm wondering, and it doesn't have to be all finished or anything like that, but obviously for the hackathon, but how much of this has been implemented?
The only parts that were not implemented was like creating the NFT. I did use, I think, Menti as a test, but the screen, the layout, that's done. Probably needs a better enhancement from a game developer, but I was able to also load the files onto, I think, Web3 storage. I use that and it actually references it, in the display. In fact, I was a little surprised that it actually worked as well as, like, so the first few screens were being referenced within the app itself. And I just wanted to make sure that was fast enough. But referencing the files directly on Web3, it was direct. You couldn't even tell the difference. In fact, there was no difference. So that kind of worked really well, and kind of showed the power of the distributed file system. It makes it almost as powerful or more powerful a blockchain. It almost looks like blockchain, the files is distributed file system, just as powerful. And you could build some interesting apps on the distributed file system that maybe use the blockchain even for something, maybe for persistence, for immutability. But it's so much faster. I was kind of, wow, I was expecting some kind of lag, but there wasn't.
Right. So you were hosting assets directly off of IPFS gateway. Is that the idea?
Yeah, well, straight on Web3, and there's a backend sending the actual file name to the React front end, and then that actually references the Web3. So that entire interaction, was done very smoothly. That's why I was kind of a little surprised.
Right.
There was no difference between like the images being displayed from within the React app versus it being sent from the back end and then being referenced from Web3. So the Web3 storage. That was pretty interesting.
Good.
So I see this as maybe a way of I think Vijay, did you have want to share something?
I know. I mean, we are already running out of time, so just one comment from my side. It's a good project. I mean, good thinking. First of all, it's but I see a lot of UI works that is still pending, which is fine because it's just a hackathon. We are here to learn. So I wish you make more and more progress, and just feel free to contact if you need any help.
All right, sure. Thanks a lot.
Yep.
All right, thank you so much, Team Brain Universe, for your presentation. That was great.
All right.
Right, moving on, I think we have Team Web3 Dev Tools. If you guys could come up and start whenever you guys are ready. So wait. Yes, I don't know where.
Yes, Viraj is asking to add him as a panelist.
There you are. Yeah. All right, Viraj. Okay, whenever you're ready, you can take it away.
I'm Viraj Anchan. For the HackFS hackathon, I worked on Web3 Dev Tools. Web3 Dev Tools consists of dev tools powered by Web3 technologies. As of now, it includes container registry and NFT detection using machine learning models, that is AI Hub. Now let me tell you about NFT detection. NFT detection uses TensorFlow keras to generate a machine learning model to detect similar NFTs based on the uploaded image. The graph protocol is used to generate the dataset required for training the machine learning model. The generated model is then pushed to IPFS/Filecoin using web3.storage. Once the model server is started, then the model is pulled from IPFS and used for the inference. NFT detection model can be used using a UI or using a REST API. As of now, it only supports the CryptoPunks NFT. The dataset can be updated to handle other NFTs too. Use cases: search NFT using an image, similar NFT detection, detect smart contract address and token ID for an NFT using an image, counterfeit NFT detection, detect NFT owner based on Twitter profile image, that is if CryptoPunks NFT is used as a profile image, These are the screenshots. Now let me quickly show you a live demo for the same. So this is the homepage for the NFT detection, and what I can do is I can select an image over here. Now I'll click on search. As you can see that it correctly identified that it is NFT number 9997, and it also shows the previous sale price and a link to buy this item, and along with that it also shows similar related NFTs to this one. And here is another example for the same. So this concludes the demo for NFT detection. Now we'll move on to the next one, and this is container registry. Container registry allows you to push and pull Docker images from IPFS and Filecoin. It provides a native Docker integration via custom Docker registry server. It is powered by Web3.storage and OrbitDB. The Docker image layers and the manifest file are pushed and pulled from IPFS and Filecoin using Web3.storage. The OrbitDB is used to maintain the mapping of IPFS hash for the Docker image layers and the manifest file. Now these are the screenshots. So this one is for the Docker registry server. So in this way we'll start the Docker registry server, and these are the screenshots for push and pull. And here is the live terminal. So here you can see that the first step is to tag the local image for your Docker registry server. So here this is the server address, and then what you will do is you'll push the image to your custom Docker registry server powered by Web3.storage, and you will see that each layer is being pushed over here. And finally you can see that the manifest file is pushed. Then to test the further steps, what we do is we delete the local images, and then what we do is we try to pull it from the Docker registry server, and as you can see that it pulled complete layers over here. And finally we downloaded the image locally, and then finally we ran a container using this Docker image, and this is the Docker registry server which is running. And here you can see the records for the various API calls which the Docker client made. Here you can see that it used Web3.storage. This concludes the demo for Web3 Dev Tools. Thanks.
Viraj,
Presentation, Viraj. Go ahead.
Yeah.
With any questions.
Viraj is on screen, or?
Yeah, I'm here.
Okay. So you're muted. Okay, so first of all, it's a good one. We at BitsCrunch, we are also working on counterfeit NFTs as well. So you can also write me. And my question is, so for this demo, I see that you use CryptoPunks, which is kind of finite. So there are limited number of CryptoPunks. But what are your plans? Let's say if you go for an NFT collection that is infinite, that is generated over and over again.
So you'll have to retrain the model periodically.
Okay. So
the way this works is like basically initially from the data set, right? We compute feature vectors from that thing, and then when a new image comes, then you generate the feature vector using the model, and then you compute the distance between those two images. If the distance is very less, then it's similar to that NFT, and then you will sort it like based on, say, if you want to see 5 similar images or 1 similar image, like the best one, or you want to see the more images.
Okay.
Yeah. Cool. So how Viraj, this is you did the Docker some of the Docker stuff in the last HackFS, right?
Yeah.
Is this is this
so
sure.
earlier I did it in 3 different ways. So one was using PowerGate, the another one was using Textile Hub, and the third one was using Fleek in the past. So this time I used a combination of Web3.storage and OrbitDB.
Gotcha. Okay. And what now? So it seems like it could have been enough to just do the image NFT detection stuff or the Docker stuff. What made you decide to do like a whole suite of tools? Because they're kind of unrelated, but
we wanted to experiment various different ways in which we could make it more popular, basically, the entire Web3 thing. So one benefit of Web3 storage is right now 1 TB is free right now. So that is also a powerful use case because of that.
Right. Yeah, that makes sense. Okay, well, we got 1 minute left. What's next? What's the next step here?
So one thing would be like to connect with different people who need the NFT detection algorithm. So that is one thing, and like say it could be NFT marketplaces or some other people, and similarly for the Docker thing, it would be to participate with various projects who are interested in the solution.
Cool.
And like during the hackathon, I also wanted to research more different things also, like say a service like CloudFront, powered by Web3, and things like backups or Redis, etc. But I didn't get time for those things.
Okay.
Sounds good. So thank you, team Web3 DevTools, for your presentation. I would just like to ask the next team, Coopart, to please come on to the stage as panelists and present whenever you guys are ready.
Hello.
Oh.
Sorry, just give me a minute. Can you hear me?
Yep.
Yep.
All right. So let me share the screen right away. All right. Okay. Coopart is the first ever tile-based NFT art marketplace. Create a canvas and add the first tile. Other artists expand the canvas in any direction and add new tiles. People can vote tiles in or out. Each canvas is its own DIO and self-governs. Some tiles are voted out, and some tiles are voted in to replace them. Canvas is sold and profits distributed to all its contributors. Hi, I'm Rick. I first got the idea for Coopart from looking at the 69 million Beeple's NFT. The piece of art is made from 5,000 tiles merged together into a common canvas. I thought it would be great if each tile was made from a different author, and so Coopart was born. Let's try it out. Go to coop.art and connect your MetaMask wallet. Make sure your wallet is connected to the Matic Mumbai testnet, as I've deployed the smart contract on the Polygon testnet. Once you are connected, your ETH address should appear in the top right corner. You are now ready to create a new canvas or contribute to existing canvases. Let's start by creating Create New Canvas. You can see an empty tile and a few options. First, choose a tile size. Note that all tiles in the canvas will have the same size, even for other contributors. Let's choose 130 pixels by 340 pixels. You can also select the time period for other artists to contribute to the canvas. Let's choose a deadline 3 days from now. After that, the canvas will automatically lock and be put on sale, meaning that no contribution will be possible. Now, hover your mouse over the tile to see its coordinates and an upload button. You can click the arrows to expand the canvas on the right side, left side, top side, or bottom side. There is no limit to the canvas size. This could technically scale to 1 million of tiles. Let's upload the first tile. Note that I am using HackFS with the Infura gateway to store the NFT images and token metadata, so it is fully decentralized and tile owners can be reassured that their art is safely stored forever. Once the image is uploaded, it appears in the tile you chose, and a transaction to mint the tile is automatically started. accept it to mint the tile as an ERC721 token in the smart contract. You can check out Polygon Scan to confirm that the transaction is indeed successful. This canvas is now officially started. You can add more tiles yourself or wait for others to contribute. Let's now go to the marketplace. Here you can see ongoing canvases that still have time left in their contribution period and canvases that have expired and have automatically been put on sale. You can see the canvas that we just created with only one tile. Let's say now that I am another artist that want to contribute to this canvas. I can click contribute and the tile editor will open and fetch the tiles from the smart contract. Note that I created a custom subgraph to fetch the data with GraphQL. Let me now add 2 new tiles to this canvas. I am now done contributing. If I reload the marketplace, I can see that the canvas does display the new tiles. Let's contribute to another canvas. Here I can see tiles about typical Rage comics. However, there is a tile here that does not seem to fit the theme of the canvas. In that case, I can vote this tile to be removed. Each canvas is its own DAO and self-governed. You can click upvote or downvote on each tile, and those with more downvotes than upvotes will be removed automatically. Now, when the contribution period of a canvas expires, no one can contribute to it anymore, and it is automatically put on sale in the marketplace. For now, I've only implemented a simple fixed price sale at 1 Matic as a proof of concept, but I do plan on developing a more complex auction system soon. When a canvas is purchased, all the tile creators, except those that were voted out, of course, are paid according to the number of tiles they contributed. For instance, if a canvas has 10 tiles and is sold for 1 Matic, each tile creator would receive 0.1 Matic. If someone contributed 2 tiles to the canvas, he would receive 0.2 Matic. Co-op art is a revolutionary way of building NFT art cooperatively. Tile-based art will lead to new and exceptional pieces from thousands of artists working together, and maybe one day worth millions.
Super cool. Very, very nice presentation. Love the idea.
Thanks.
And yeah, quite original. That's great. Can you tell us a little bit more about the tech stack that you're working with?
Yeah.
I didn't catch how. Yeah. Just go ahead.
Yeah. So the front end is made with React, and I'm using the HTTP IPFS client to connect to the Infura gateway to upload the stack. I'm using RDAT to deploy and compile the smart contracts. I'm deploying everything on Polygon. I'm also using a custom subgraph to fetch data with GraphQL. And I think that's it. I'm using TypeChain because everything is in TypeScript.
Nice.
And yeah, that's about it.
Cool.
So like Carson said, it's a super cool idea. And then did you already started building a community or spread the word around this project, or what's the current status?
So I started working on this like 3 weeks ago. If you look at the description on the ETH online website, because I don't have enough time in the video to explain everything, but if you look at the description and the submission, you can see that I have divided the project in 3 phases. And the first phase is a tile art editor with a simple sale. And in phase 2 that I'm going to start right now until the next hackathon will be based on layer cooperative art, which is another form of cooperative art with auctions. And yeah, I'm gonna build some more stuff until the next hackathon.
Okay.
And I would like to ideally release it on the mainnet in September.
Is it great? Cool.
Yeah.
Right, yeah, that's all the time we have for Team Coopart. So thank you for presenting.
Thank you.
All right. So actually, right now, I'm just gonna share my screen real quick. because we are going to be taking a quick 10-minute break before we go on to the last few teams. So we'll be back. Okay, let me just put the time here real quick. At 1:43 p.m. Eastern. Yeah, everybody just take a break, relax, and we'll be back by then. Thank you. All right, we are back. Okay. I'll stop sharing my screen right now. All right. So team inline meditation, I would like to give you guys a warm welcome. If you guys are ready, whenever you guys are ready, you guys can start and present your video.
All right, hello.
Hello.
Should I start?
Yeah, you can go ahead.
This is Inlight Meditation. It is a mobile-first web app for tracking meditation and creating NFTs for each session. One possible use case could be that you can imagine organizations like not-for-profits deploying funds into supporting meditation by buying meditation NFTs in a similar fashion as in the present day individuals donate money to charities for specific causes. The technology stack I used was React.js, Next.js, Tailwind CSS on the front end, NFT.storage, Hardhat, and the network Polygon. Here is the profile page. You can click to edit the first and last name and the longitude and latitude, and this can be automatically filled in using the browser API. On the meditation page, you can set the meditation duration and press start. When the meditation completes, you have an opportunity to update the user information or the location. You can see the duration and the start and end timestamps are set. You have an optional description field. You can update the Ethereum price, and you have an option of uploading an image or using an automatically generated image, and this image can be of your meditation space or anything you like. The image is uploaded to NFT.storage along with all of the other metadata. You can, so now to mint the NFT, press create meditation asset. After the transaction is approved and it is minted, you can see that it is on the marketplace and on the store page. So now to buy one, to view all of your meditation NFTs, you go to the list page. You can see all the ones you created, all the ones you bought and sold.
Cool. Thanks for that. Great presentation. Very quick and clean. Thanks.
আজকে আমাদের টপিকসে বেশ কিছু এডিশনাল টপিকস থাকবে। এর মধ্যে থাকবে হচ্ছে কিভাবে লোগো তৈরি করতে হয়, কিভাবে ফেসবুক বুস্টিং করতে হয়, তারপরে কিভাবে রেকর্ডিং করতে হয়।
Sorry, that was me. Okay, that was YouTube. That's the
Okay.
Okay. Yeah, wondering who was talking there. So can you explain to me, I didn't, what would be like a use case where someone buys someone else's meditation NFT?
It could be to have like a souvenir or to support someone's practice, or to support like you can maybe restricted by a geographical area or a certain group, then you could like buy those to
Gotcha. Okay.
That's almost the same question that I had in my mind, Carson. So yeah, it's for the niche community. I mean, not everybody is into meditation or exercise, so it's a good one to promote meditation as such, and also in a way to bring this NFT community together. I still see some yards to cover, but yeah, good work so far.
Yes.
So in terms, because I mean, I don't know, the meditation like app space is actually huge, right? Like there's a lot of features that different meditation apps and things use. I'm not a big meditation person myself, but my wife is quite adamant, or does a lot. So what in this first implementation, what's missing? What's the next sort of like feature, and how does that feature, how might that feature leverage the fact that we have a blockchain here that we're interacting with, like that we have NFTs, you know, that's something like you just couldn't have done before, right?
I have a couple of general ideas. I'm not too focused on like taking this further as into a business. This is mostly because to learn and write a smart contract and kind of I'm just getting started out in this space. But I also wanted to, I was imagining like using the unlock protocol and allowing for more of like a social media platform where users can follow some meditators and have access to some special content from them that way.
Yeah, that's cool. Nice.
Do you have any other suggestions for improvements?
Well, I think that idea there is pretty powerful, right? Like you, in theory, you have a reputation for someone who maybe leads like really interesting or deep or useful meditations that, you know, you might want to buy their NFT from like a past meditation in, or like a past session, in order to then like revisit it later or something like that. Like there is certainly a sort of like way of like, yeah, the social media application or social application where people could like experience meditation that someone else has done, or I think that seems like a pretty powerful, you know, it would be a way for, you know, people who lead meditations to monetize their skills.
Yeah, I think that's it. Thank you so much, Team Enlightened Meditation, for your presentation. Okay, up next, I would like to welcome Team Web3 Dark Mode. If you guys could please turn on your cameras and share your presentation for us. All right.
Hi, I am Chris, and this is Web3 Dark Mode, a Chrome extension that lets you edit any website CSS and share it over a decentralized storage network. You can use the extension, for example, to turn your favorite blog dark so you can read it at night. Or really any website. For example, you can invert colors on Google Docs. Or on Twitter, you can also use it to block ads or block distracting elements on the website. You can also use it to increase font sizes and buttons, for example, on DeFi websites, to increase accessibility to people with reading impairments. And finally, you have the options page where you have an overview of all your changes, where you can log in with Ethereum and sync all your changes in a dedicated ceramic schema. And finally, you can view the feed of any changes that other people uploaded. You can follow changes, follow lists, and you can rate them And the rating, first of all, helps to sort the list because then you can show the most popular ones on top. But it also attaches kind of reputation to any editor's identity, to any editor's Ethereum address, right? And that's the motivation behind starting this hack, sort of to have this useful tool that lets Ethereum users help each other without requiring too much technical knowledge. And this way bridge reputation from the Web 2 to the Web 3 to Ethereum addresses, right? This is really an alternative approach to, let's say, legion scores or KYC or any of the Sybil resistance protocols. And once people use this extension, the information about valued relationships in this new network will help with decentralized governance, quadratic voting, funding, and so on. Thanks for listening. Happy to hear feedback. Yeah, thanks.
Cool. Well, I'm going to start with the same question I start with most teams, which is, can you tell us a bit about the tech stack that you were working with there?
Yeah, sure. So basically, the front end is JavaScript and Vue.js. And for the backend storage, we use Ceramic and store it locally, but you could also plug it into AWS or HackFS, for example. And then the identity part also Ceramic, right? So you map your Ethereum addresses to decentralized identifiers, and you could map it as well to your Twitter or GitHub, any like Web2 social account.
Does it depend on any browser, like Web 2 browsers or Web 3 browsers, or it is independent of the browser?
Oh yeah, so I mean the whole thing is a Chrome extension, so you could use it in Chrome and Brave, Chromium.
Okay.
And to authenticate, you need MetaMask or any other Web3 wallet. Yeah.
Okay. So right now you have it for Chrome and Brave.
Yeah, exactly.
Okay.
And so maybe you can go through how, so say I come up with a pretty sweet, theme setup, and how would I share that? How does the sharing work with other peers? Can you just go through that again?
Oh yeah, sure. So you start by logging in with your MetaMask and then generate a DID in Ceramic. Like the first time you actually use Ceramic, and then the other times you just log in with your MetaMask. And after that, you use the Chrome extension to make some changes on the website, some CSS changes. And then there's a button to upload those changes. And then on the other side, the second user, he sees those changes saved in a list. So different lists could have different names, right? Like accessibility or minimalism, focus, or like dark mode or anything. And in like the next version, you could also do the same thing with JavaScript. So you could do something like in advanced ad blocker or something like Grease Monkey, if you know that. I don't. Yeah.
And so the registry where the tagged, where you basically tag your changes, and is that indexed with the graph or anything like that on Ceramic?
So no, I guess you can, so you use Ceramic to sort of standardize the data. Yeah. Right? That you have this, that you have a standard for these lists and for changes, and then you can really save it anywhere. Right? Like I said, in HackFS, for example, is like decentralized storage network on AWS or just locally, and you share it with a Bluetooth or a USB stick, right? But that determines how you can index it, but not with the graph, right? Like it's not on chain.
Okay.
Okay, if there's nothing else, then I'll assume that all the questions have been asked, and we'll move on. So thank you so much, Web3 Dark Mode, for your presentation.
Cool, thanks guys.
All right, then up next we have Team Pulp. So if you guys could please unmute yourself or turn on your cameras and share your presentations, please. Thank you.
Hi everyone. This video is only slides, so I'm gonna talk over that if that's okay. So my name is Dan. Can everyone hear me all right? Yeah. My name is Dan. I'm one of the members of the Pulp team. I'm joined today by Brahma Sen. We hail from Boston, Massachusetts, and Columbus, Maryland, respectively. Before we start, I just want to disclose Pulp is an existing project. We actually participated in HackFS last year. And I'd like to emphasize that we're only submitting work completed in the last 2 weeks for judging this year, and I'll highlight that work in the demo. So just a little quick background on Pulp. Pulp is a publishing platform, so think Substack or Medium. And traditionally, the publisher sits kind of in between the author and the subscriber, and they intermediate the relationship, which gives them eventual control over the author's revenue stream. But Pulp actually replaces the publisher with an open protocol. This effectively commoditizes the services of the publisher into easily replicable, low margin software nodes. And in developing Pulp last year, we anticipated a quality problem. I call this the 8chan problem, with no offense to 8chan. But the problem is that a totally free speech platform initially attracts kind of the lowest common denominator posters, and then you get this negative feedback loop that tarnishes the community and drives away any would-be high quality content. So our hack this year sets out to solve this problem. With distributed tech, we have the unique opportunity to unbundle the editorial board from the publisher. And in traditional media, the editorial board acts as kind of a content filter. This is analogous to the Twitter or Facebook terms of service. But once you unbundle the editorial board from the publication, you have the opportunity to implement a market of editorial boards with a many-to-many review pattern. And this creates a quality filter rooted in pluralism. There's no single authority on what should or should not be propagated, but we end up kind of with quality metadata that can be used by subscribers to make decisions about who or what to read. So we've updated that in the PNLP protocol shown here. And we also decided to use HackFS as an opportunity to integrate with Superfluid to facilitate revenue streams for authors. So I'll demo all of that quickly. So the reference implementation is a React app. And I'm going to begin here by quickly adding some test content. This is all in our existing app, so we can demo the 2 new features that we built for our hack. Initially, I'm acting as an author. I'm using MetaMask for identity. I'm starting a new publication, and I'm writing my first article. So these artifacts are indexed on the Ethereum blockchain, and they're persisted on IPFS via Textile. Once this is complete, I'll switch MetaMask accounts to act first as an editor and then as a subscriber so we can demo our 2 new features. So here, I'm an editor reading this article published by somebody else. And upon reading the article, I can choose to approve it or reject it. This information is persisted to the Ethereum network. And once my transaction completes, all future readers of the article can see my approval. You can see there. And as with any data in Pulp, we can view this information on the Ethereum, on any block explorer. So here we bounce over to Etherscan and we can see that transaction successfully. Next thing I'm going to do is act as a subscriber. So I can go back to the UI, I can read somebody else's article, and I subscribe to their publication. I've set the subscription to be 1 XDAI per month, payable directly to the author's address. This opens up a Superfluid stream for a continuous subscription flow. And again, we can see this information in any block explorer. So I'll bounce back over to Etherscan. We can see the transaction successfully complete. And then we can also go over to the Superfluid dashboard and we can see our 1 XDAI per month flowing from the subscriber to the author as we would expect. So that's what we've got. We're happy to answer any questions, and we want to thank the judges and ETH Global for putting on another great HackFS.
Cool, nice. Well, you kind of went over your tech stack, so my default question has been stolen. Thanks a lot. But that's pretty great. So can you tell me a little bit more about the Superfluid setup? Would you say that's like a biggest component of what you did at this HackFS, or
yeah,
the bulk of the work for this?
Sure, the work. I mean, it was pretty evenly split. We added what I would call the review functionality, and then the subscribe functionality. The review functionality was just Solidity. There's nothing super magical going on there. It's just updates to our Solidity contract, and then the associated updates on the client to to handle the reviews. And then the other probably even half of the work was we had never used Superfluid before. We actually were introduced to it through HackFS. We saw them as a sponsor, and we decided that that was actually one candidate technology for implementing subscriptions, and we wanted to experiment with that. I should note that the subscribe feature is not gating content at the moment. So, you know, you're paying the author, you're sending money to the author almost pro bono. It's not like we gate the content that is on the publication when you open up a new subscription. And obviously that is an important feature that is kind of on the roadmap for us. But at the moment we're just sending value from the subscriber to the author.
Well, you could, for now you could just, yeah, go ahead, Vijay, you go ahead. I'm sorry, I have an emergency in the background, so I'm gonna have to deal with that.
Okay.
Good luck.
Oh, Daniel, I'm just not clear about the business model that you guys are thinking about. Can you please elaborate on that a bit?
Yeah, good question. So I see, I mean, there's a few ways you could potentially monetize a service like this. I think there's room to monetize as the builder of the client, where if you end up facilitating at least some large portion of readership, then you could ask to take a cut. The whole idea of Pulp, though, is if you think about Substack charges 10%. The idea is that those clients end up being kind of commoditized software, very low margin software. So, you know, that's not like VC area activity per se, but you know, you hopefully end up being able to make a little bit of money on running a node yourself. I think there's other monetization area around aggregation. So if you end up becoming a destination for subscribers who are looking for authors, you can translate that into a little bit of monetization as well. Two thoughts among many other possibilities.
Good. Okay. Yeah, I guess we are running late. So good work.
Great. Thanks, guys.
Yeah, keep going.
Thanks.
Thank you so much, Pulp, for presenting. Carson, are you fine to move on?
Yeah, I think so far. I think we're okay. Yeah.
Okay, good. Sounds good. That's fine. All right. So I would like to welcome, I think it's Journalist, to come and present your project.
Everyone, I'm Riley.
Last presentation for the day then.
Sounds good. Yeah. I'm going to share my screen real quick. All right.
Live. This is a submission to HackFS called Journalist. Real quick, our team is myself on the right there, Griffin, and then Riley on the left there. We're both based in San Francisco. Our project. So it aims to address updates and additions made to articles after the time of publication online. Some publications use a footer or a header to indicate when they've been edited, and that's great. However, it relies on the publisher noting what changed and when, which comes with its own problems in tracking. And then there's no easy way to verify and view these changes, sort of like a git diff, where you can see what changed between article versions. So we aim to tackle this with smart contracts and IPFS on Ethereum. So the way that it works is an author publishes their first version of an article. We then upload this article via smart contract to Ethereum's blockchain and store it there. And then the text of the article itself is given to IPFS, and then we get the unique ID associated with that text. And via our smart contract as well, that article now points to an array of all these different CIDs. So anytime this article is updated on our site, we store a new CID, unique identifier, to the text of that edit. So now, because we have all these different versions, we're very easily able to diff or view the changes between these versions via our UI. So speaking of the UI, let's go ahead and jump into that. So let's create a new article here. Article name, 123. So we can fill it with the default address here, but normally you'd, as a publication, you'd approve an author's address, so random people can't just publish to your publication. Let's go and get some random text here. Fill that in. We're going to upload to IPFS. Confirm this transaction via MetaMask. Now you can see IPFS, whoops, IPFS has been uploaded to IPFS. You can see the unique CID here and then the text of the article. Great, let's dismiss that. Let's go to our articles here. You can see this new one, article 123 at the bottom, but oh crap, we made a mistake. We need to edit something. So let's delete this first sentence, which is an error, and we can say, we fixed the error. Great, let's upload this to IPFS, a new edit, confirm this transaction, and then again, this success, and we can view the new version on IPFS if we want. Go ahead and dismiss that. Go back to this articles view, and we can see now that it's been updated. Click this new view. Now we're on the diff view. You can see the version 1 and 2 here, and then via our diff here, we can see that in red, the change that we made, and green, the thing that we added. Great. So that's pretty much our app. Future plans, we didn't get to the full publisher UI. We finished the article or the author UI, but we want an ability to be able to add authors to our publication, like pre-approve them, and then the ability to not only view like an author's articles, which we currently have, like all the articles that an author has published, but also as well as all the articles published under a single.
But yeah, that's our project. And yeah, I think cut the video off at the end there, but I think we would also plan to like deploy to a layer 2 scaling solution.
Mm-hmm.
So where is the smart contracts running on like a test net right now? I didn't catch the.
Yeah, we haven't deployed them to a test net, so we've just been locally like using Ganache, just testing it.
Cool. Yep.
So you're planning to deploy it in Polygon, right?
Yeah.
Okay. Any main reasons for that, or it's just the cost factor?
Yeah, just a cost factor, and just like probably the layer 2 solution I'm most familiar with that we've both used.
Mm-hmm. Okay. Yeah. Any other questions, Carson?
So I saw that your future plans are for maybe some sort of like persistence, framework or something like that. So is the idea there that you would persist like all past copies on Filecoin or something like that in addition to just IPFS?
Yeah, that would be the plan. So then you get to like maintain that like the versions, and then you can see like any differences that were made.
Cool. Okay. And then maybe another question would be, so in addition to the obvious, like you can diff and see what the changes are.
Yeah.
Do you envision this being used like as a tool for journalists to track, to flag incorrect content and like as an actual sort of like transparency tool?
Yeah, I think like in my mind, there's a couple things it would be useful for. Like one, is like a transparency tool. Like then you get that like transparency as a journalist, which could be a benefit for you. And then another thing too is just that it's like decentralized. So you have this like censorship resistance. If I don't know, maybe you're a journalist that needs that. So I think those are the kind of two like benefits that I would see for journalists. And yeah, we had like the future work was the publisher side, which would kind of solve like part of the issue of people just like posting whatever they want, or like bad content. You could go to like a specific publisher address, and then it would just show articles of like the journalists for that publisher. Yeah, kind of similar to Pulp. So funny that we ended up going right after them, but
right. Yeah. Well, I mean, yeah, these are all important ideas that people are tackling, so some overlap is okay. Okay, we got 1 minute left. BJ, any questions to finish off with?
Yeah, even I could see some similarities to Pulp. It's really weird that they were placed right after each other, but it's nice. I mean, but still you need to work on the UI part. But I see it's just a couple of weeks of hackathon. So once you get the UI done, then it'll look really cool.
Yeah, definitely. Yeah, it sounds good.
And there's the plan to keep working on the project?
Yeah, I think so. I think it was like mainly seen as just like a learning opportunity for us. This is like our first hackathon and like working with Solidity. But I do think it's pretty interesting. So yeah, we'll probably like flesh it out a little more.
Cool. That's great.
Yeah.
All right, fantastic. So thank you so much, journalists, for your presentation. And that was our last team. So I guess I'll wrap it up really quick. All right. So that's it, everyone. And I just want to say thank you for all of our participants for taking the time to create and present these amazing projects. All very well done and very interesting as well. And of course, I would like to give a big thank you to our two judges, Carson and Vijay, for helping us out today. And again, thank you guys all for coming out. And I hope everybody had a wonderful day. Take care.
Thank you.
And yeah, Vijay and Carson, I'll just give you guys a quick reminder. You guys need to connect back with Kartik for your score tallies. So yeah.
Okay.
Is it the same link or the same link Kartik already sent, right?
Yeah, it should be.
Okay. Yeah. Okay.
You sent us a separate link for that?
I don't know. The same link that we used before this call.
Oh yeah. Yeah. Cool.
Sure.
All right.
Yeah. Bye-bye.
Okay. Yeah, so take care. Have a great day.